Hi, my name is Henry Brill, and this is video number 2, the projectile motion question. All right, so the question: a gun is fired with muzzle velocity 904 feet per second at a target that is 3,400 feet away. Find the minimum angle of elevation necessary to hit the target. Assume the initial height of the bullet is 0, neglect air resistance, and give your answer in degrees. All right, so the first step is to write down the given. So muzzle velocity, that's just the initial velocity. So V0 equals 904 feet per second. All right, and then we have the target, which is 3,400 feet away. We could interpret this value as the range. So it's the same thing as saying the horizontal distance, but I'm just gonna call it range equals 3,400. Bad zeros. Okay, yeah, 3,400 feet. So this kind of seems like a complicated question, but it's really just one formula. So to solve this, we could use the range formula, which you could derive from like the projectile motion equations, which comes from like breaking down the initial like velocity vector into its x and y components. But we can just use the equation for it, which is r equals initial velocity, um, initial velocity squared, um, times sine of 2 times the angle of elevation, or just the angle, like just the angle. It could also like I guess angle. Over gravity, and and I guess another given would be that gravity is equal to 32 feet per second per second. So yeah, now we can substitute our given values in, and solve for the angle. 3,400 equals 904 squared times sine 2 theta over 32. Now I guess we could plug this into Desmos, which I did right here. Same equation, except I'm using x instead of theta because theta doesn't recognize it as a variable, so we're just gonna have to assume x is theta. And I get a value of around 3.83, 3.82. I mean, depending on your value for gravity, it could vary. Like if we were to use a more accurate, like 32.2, it would be closer to 3.85, but I think the textbook says 3.20, so yeah, I mean, I guess just go with 3.83 as a, well, I think it's slightly closer, yeah, 3.83 as a, like, accurate value. Actually, I don't know. I think 32.2 is, I don't know. Yeah, so 3.83 degrees. Yeah, that's it. Thank you.